So the first video for this section looked at the pieces we're going to need to do a two-sample test. Now we're going to go through one example using a critical value method, and we're going to be looking at the match pair test. Okay, so dependent symbol match pair test is where the observation units are going to have two readings, a before, after, something where we're going to have the same observational unit being watched multiple times. Okay. My grandmother's old. She's at the age where a lot of her friends are starting to forget things and act a little different. She's scared that she's going to get Alzheimer's disease. One way doctors test for Alzheimer's is that they have you list as many items as you can for a specific topic. My grandmother thinks that she can practice and beat Alzheimer's. Below are two sets of data. One listed from 2008 and the number of items she could list for 12 different topics. The second list is from 2009 on the same topics. The list numbers correspond with each other. Run a test for significance. Is my grandmother slipping? Show all work. Be 95% confident. Okay, so what they're saying is 2008, 2009. The first number, 34, 33, those are corresponding. That's how many items she could list for that same topic. So that's what it means by they're corresponding, that each one of these is a pair. You have the number of items she could list 2008 on one topic, then in 2009. Okay, so just like before, we're going to list our null and alternative first. We're going to start off with our null and our alternative. And I'm going to have mu 08, okay, that's the average of 08 equaling the average of 09. The alternative then, I'll start off just 08, 09. Now, we're going to see if she's slipping. We want to see if 2009 is less than 2008. If they are less than 2008, that means that she's not able to list as many items as she was in the past. So I'm going to have greater than. Now, this is important because that's how we know what our critical value is going to be. That's going to help us with our critical value. Because now I'm drawing my curve. Okay, I have my normal curve there. Since it's greater than, okay, there's going to be a right tail test. So now you're going to go to your T-chart. You're going to look at one tail. It says be 95% confident. So remember, that means our alpha level is 0.05, so make sure you look at the right column. Okay. We have 12 pairs here. So since there's 12 pairs, n equals 12. That means that we're going to be looking at 12 minus 1 degrees of freedom. So degrees of freedom, 12 minus 1 is 11. So there's all of our information. One tail, degrees of freedom is 11, and we're looking at 0.05. And we should have a critical value of 1.796. It's positive because it's on the right-hand side. So remember, normal number line, positive on the right-hand side. Now we have to go get our test statistic. And we're going to be using the list of data. We need to find the difference between the two lists. So you could go ahead and subtract each one of these. Take your time, 34 minus 33, 31 minus 27, 52 minus 53. A fast way to do this is if you plug the 2008 list into L1, the 2009 list into L2, and let the calculator do the subtraction for you, and let the calculator store that list into a third list, and that list will be the difference. Okay, that will have all the subtraction done for us. So what we're going to do is type in L1 minus L2 store L3. And if you do that in your calculator and then go back to your list screen, you'll see a third list in there, and it will have all the subtraction. You can do a couple of them to make sure, just if you don't believe me that's on a work, to make sure that those are the right values. But now that L3 is the list we're going to use to find our test statistic. And we're going to need our average, we're going to need our standard deviation, and we're going to need our n. So all that can be done using one variable stat with the list of L3. And if you want to stop, go do that real quick. Make sure our numbers match up. Okay, we should have a sample average of 2.1 2.167, a standard deviation of 2.623, and a sample size of n equals 12. Okay, so going ahead and plugging all this in. These are all the difference. This is all from L3. 2.167 divided by 2.623 divided by square root of n. And I'm going to make sure, oh, I'm sorry, should be square root of 12. I put n in there instead of 12. I'm going to put parentheses around that numerator, the denominator. Okay, just because order of operations, make sure you have that denominator in parentheses. So our test stat then, I have it as 2.862. .862, and now we're just going back to our curve, and then all this is the same as the last section. We have our fail to reject. We have our reject, and this is all talking about the null, and I'm going to look where that 2.826 lands, and we would see that it lands in the reject area. So we are going to reject the null. Okay, so think about what that means. Rejecting the null means that there is evidence to support the alternative. There's evidence to say that 2008, the average was higher than 2009. In 2008, my grandmother, on average, could list more items than she could in 2009. So if we have to put that into words, they say and take a look at all the work we did. Null alternative, we drew our curve, went to the chart, found our critical value, found the difference of our two lists, found the summary stats, and then plugged it into the formula to get our test statistic. I'm going to erase all this. This is what I have on the screen now. Okay, we rejected the null. We are rejecting the null, so we side with the alternative. There is evidence to show that my grandmother's memory is not as good as it was in 2008. Okay? So they're the steps of doing a critical value method. Okay? Work through those steps, rewind it, go through again. It's a process. If you remember the process, you should be able to work through to get to our final answer.